Hello. In this video, we're going to take a look at a baseball study with focus on memory usage. There are many resources that contributed to this lecture, so I want to acknowledge those people. So the first thing we're going to do is we're going to import pandas as PD, import OS, and then try to get the file size of this file. So it shows if you read this file into a data frame, you look at the head, it shows that data frame has certain mixed types in columns. So at least we identify something that's quite important. So a data frame looks like this: the date, number of games, day of the week, and so on. And it shows 5 rows and 161 columns. So there are 161 features in this matrix. So our goal is to find out the memory usage. So if you look at how much memory is used by this data frame, if you ask that question, it says it's using 860 megabytes. It has 77 float, 64 types, 6 int, and there are 78 objects, and so on. And there are rows, 171,000 rows, indices from 0 to 171,906. So although the original file, I believe it's about 136 megabytes, once you read that into a data frame, it is bigger. It's almost like 6 times the original file. So in order to reduce the amount of memory storage here, we have to take care of a few things. One is we have to perhaps reduce the size of the data. Maybe we don't need float 64, we could use float 32. Those are 32-bit. In theory, we save about half the memory. And then some of the objects can be converted into other types rather than objects, so we could save some things there. So pandas data frames, under the hood, the panda groups the columns into blocks of values of the same type. So for example, if you look at our data frame, it looks like this, but you can see that pandas will represent this data frame in blocks of integers, blocks of objects, and the float blocks. So this way it can optimize the memory storage required for each block rather than trying to keep it like this. So we can find out the memory usage by each data type. So for each data type, float, int, object, we try to find out the amount of memory use. So the average usage for float column is about 1.29 megabytes. As we know, we had like 161 columns. Average usage of an object column is about 9.51 megabytes. So that's a lot of memory that's being used by these columns. That's per column, and if you add, if you multiply, you get things. So some of the things we know as computer scientists about how much memory is used by specific types. So we have in Python or pandas, we have int 8 through int 64, depending on float 60, 16, 32, depending on how many bytes you use. And unsigned int can be double the size of the signed ints. Datetime is a different type of an object. And then also we have variable type objects, which are really stored as objects. We can also look at the size by calling info on any data type, uint8 through uint64. We can look at the range of values that are represented by these data types. For example, unsigned int is an 8-bit integer, which goes from 0 to 255. On the other hand, the signed bit goes from minus 128 to 127. So if you're not too concerned about negative numbers, you could use an unsigned int and get twice the range from the positive side. So similarly, we can measure other things. So one of the things we want to try to do is optimizing numeric columns with subtypes. So we can use the function pd2numeric to downcast, that's the key thing here, our numeric types. So this function written by Josh Devlin shows that we can look at any panda object and look at the memory usage of that panda object. For example, if you look at int frame, So this is including all the integer columns. And converted int is that we ask these columns to be downcast into an unsigned from just int. Then we look at the memory usage of the original frame and the int columns of the original frame and the int columns of the converted page. And we find out in this case there's no real difference in the integers, so we continue to look for other things. So here we do the same thing for floats. So we downcast from some float to another float. So now we save about half the memory. We went from 100 megabytes to 50 megabytes. So it shows that before it was float 64, there were 77 of them. Now we have float 32, so that's 32-bit, 77 of them. So we were able to save about half the memory there. So if you look at the optimized now DF converted to int columns, and if you look at the memory usage of DF and optimized DF, there's not much changes after there's a little bit of change, but not much after you do converted int and converted float. So one of the things we need to understand about how Python or pandas store data is that pandas uses NumPy arrays to store data in the C-style contiguous block of memory arrays. So it has a head and data pointer and dimensions and the strides. That's like an offset for accessing this data. On the other hand, the string data is very inefficient, so it can be all over the memory. So it could cost a lot of time to access it, as well as it costs a lot of space to store it. So we could try to get the size of each of the things here. So that's all fine, but let's talk about probably one of the best optimizations you can get. You want to optimize object type using categoricals. So for example, if you only have few categories, say red, yellow, and blue, and we could replace them by some integers. So underlying data when converted to category stored as int 8 in this case. So we go from objects here, or strings of variety of length, to just an 8-bit integer, which is
okay. So the data cleaning and EDA cycle, which can be very long.
To do this,
in this case,
we're going to make a copy of our data frame
conclude anything.
for the object types.
We might replace something with something else,
the
and we might
so that
visualize
we can see
two variables to understand how they look. We might plot three columns.
So these are the columns.
So basically, you clean the data, you take a look at it, you clean the data, you take a look at it, until you're convinced that things are looking okay for.
But if you look at the number of uniques in the day of the week, only 7
So next we're going to take a look at the NYPD data set that can display some of the
problems and
the other
issues,
things.
so you have a bunch of
that
things where the number of unique things are not that big. Like these things, we don't want to do it because these are not going to give you much, but these things will, right? So you can go from very large number of things to few uniques represented by 8-bit integers. So what we're going to do is we're going to take for example, day of the week. We're going to try to convert that. So we'll look at the day of the week, and then what we're going to do is we're going to cast the day of the week to a category type. So we say day of the week would be a category now. So it is represented by mappings between day of the week and a number here. So now, if you want to find out now the memory usage by the original day of the week, which is a string, with the current day of the week, which is a category, we actually save a lot of memory here. We went from 9.84 megabytes to 0.16. So the memory usage of the day of the week has reduced substantially. The drawback is that cannot do any arithmetic with category columns, cannot do min-max type operations. So some rules use the category type primarily for object columns where less than 50% of the values are unique. If all of the values in the column are unique, then the category type will end up using more memory, so you don't want to do that. So let's try to put together things together here. So we go from all the object columns, we converted them to the category columns. And then we look at the memory usage of the object columns and the converted object. And if you look at the before and after, it has gone from 751, the entire frame, to 51. So you can see some of the before and after conversions. So mostly if you combine this with the rest of the data frame, so we will see that the optimized data frame uses only 110 megabytes. We could use more optimizations so we could convert the data and type and so on. So there are a lot of things you could do to optimize things. All right, so we're going to conclude that lesson here. So that's an example of how to optimize things